So far as the resonance of anisole is concerned, here that is the anisole. See, aromatic ether, you write the resonance of anisole. Anisole is OCS3, and this is what actually the structure of the anisole. Now this lone pair is shifting to this point and this electron is out here, which is the structure 1. Now CS3 double bond, negative charge, and that is the lone pair. And what charge? Positive charge. Next time this electron is shifting and to this point, and then we get it further, double bond OCS3, positive charge, lone pair, then this time this pi bond is out, delocalization of pi bond, double bond OCS3, lone pair, positive charge, and then this lone pair is here, this will be, and this will be there. So OCS3 and then this. So it is the structure 1, 2, 3, 4 and the 5th. Second, third and fourth are, you can say, the intermediate structure, and these resonating structures prove that the anisole, like chlorobenzene, like phenol, you see, are ortho and para directing in nature. But ortho is the minor product and para is the major product. First, after the discussion of methods of preparation of ether by taking Williamson synthesis as well as dehydration of the alcohol, I have already provided the mechanisms of diethyl ether. There you have to learn these two methods which already in your textbook. First was the Williamson synthesis, that is applied for the symmetrical ether as well as unsymmetrical ether, and that is the dehydration of the ethanol with concentrated sulfuric acid at 413 Kelvin to produce only symmetrical ether. I have given you the mechanism of diethyl ether by taking the ethanol. Now after that, we have already prepared the anisole. Now after the discussion of resonating structures of anisole, let me take some important electrophilic substitution reaction of anisole. Anisole is very common name is methyl phenyl ether, methoxybenzene or anisole. Important electrophilic substitution reaction is halogenation. Now we can add Cl2 or Br2. Right? Take the anisole. As you know, it has positive mesomeric or positive resonating effects like chlorobenzene, like phenol. They form ortho and para products. Para is the major and ortho is the minor. Why? Because more the symmetry, more the stability. And in para there is no steric hindrance as such. Isomers of ortho and para products are obtained. See, you take the bromination in presence of mild acid. This is acetic acid. Take 2 molecules of anisole. This is the H1 from the ortho and another H from the para. That's why we have taken 2 molecules of Br2. To balance the reaction, it is the 2-bromo anisole and other is the 1, 2, 3 and 4 4-bromo anisole. So you can write the name, it is the minor and it is, what is that? Major product. So the nomenclature is in IPAC system 2-bromo anisole and this is the 4-bromo anisole. See, or you can say ortho and para bromo, common system, anisole or methoxybenzene. Dear students, you take the other reaction is the nitration. You take anisole further, and this is the concentrated nitric acid and sulfuric acid. It is a concentrating mixture, nitrating mixture. The role of sulfuric acid is to remove the water molecules, and it is the nitration which provides the electrophiles that we have done the mechanism in the previous class. Okay, so I hope you understand better. Just to carry the previous reactions, replace the hydrogen from ortho and para position, and to elaborate the structure of anatomy of nitric acid, it is actually HONO2. We take two molecules, 2 times waters are lost, and one becomes 2-nitroanisole or ortho-nitroanisole plus para-nitroanisole. You write here 2-nitroanisole, and this is the 4-nitroanisole. This is what product? Major product, and that is what product? It is pertinent to mention the major and the minor products. Approximately major products are obtained as the yielding is 81% and it is the 19%. So these are separated by the fractional distillation. Just to go for the third electrophilic substitution reaction of anisole is the very important is the, you can see, Friedelkraft's reaction. As you know, Friedelkraft is of 2 types. Friedelkraft alkylation, that is taking place with the help of the alkyl chlorides CH3Cl or C2H5Cl, and other is the acylation. In previous unit we have explained you in case of chlorobenzene that the same way I have explained alkylation as well as acylation. You take the anisole further and then provide here ClCH3, I mean CH3Cl in presence of anhydrous AlCl3, that is the Lewis acid, or FeCl3, that is the Friedelkraft catalyst. So say hydrogen from the ortho as well as para. Take 2 molecules, lost is the twice HCl, OCH3, and this is the CH3, and other is the CH3. Anyone can tell me the nomenclature is that? This is the 2-methyl anisole and other is the 4-methyl anisole. This is the 1 and this is the 2. Here it is the 1 and it is the 4. Either we proceed in clockwise direction as well as anti-clockwise direction. This is the 2-methyl anisole and this one is the 4-methyl anisole. This is the major product and it is the minor product. Just to go for Friedelkraft alkylation. See, alkylation is carried out with the help of, you can say, acetyl chloride. Friedelkraft acylation. Right, you take OCH3 and then 2 molecules, replace the hydrogen from ortho and para position. You take CH3 CO whole twice O in presence of AlCl3, that is the acetic anhydride or ethanoic anhydride, right? That it becomes CH3 C double bond O C double bond O CH3. You take 2 molecules to balance this reaction. What is lost? 2 molecules of acetic acids are lost, and that group is to be added there. There you see anisole, but here C double bond O CH3 and COCH3 C double bond O. Tell me anybody the name of this compound here? It is the ketonic group and it is the ether. Obviously ketone is given the preference, maximum priority, minimum number as far as the IPAC system of nomenclature. So dear students, it is 1 and it is 2. So this is the 2-methoxy acetophenol, and 1, 2, 3 and 4-methoxy acetophenol. So here write here 2-methoxy acetophenol and 4-methoxy acetophenol. Ketone whenever on the benzene, it is the acetophenol, and then it is the minor and other is the major. Am I clear to you? Just to go through the reactions mechanisms, and then the other is the either you take acetyl chloride or you can take acetic anhydride, product will remain same. The way I will write here that this reaction can be carried out. This is the anisole plus Cl C double bond O CS3 in presence of AlCl3. You take 2 times, that is the OR. Replace the hydrogen from ortho and para. Twice HCl is lost. One is the minor and other is the major. So you can change acetic anhydride or you can take acetyl chloride or ethanoyl chloride. This is the actually ethanoyl or acetyl chloride. This is one of the important acid derivatives that we have learned in the previous class. Right, so these are the important reactions of electrophilic substitution reaction of anisole.